Hello, everybody. Welcome to Quadratics Day 1. This whole unit is going to be about quadratic equations or things that look a lot like them. Quadratic equations, just to remind everybody what those look like. Quadratic equations look like this, like x squared plus 3x minus 4 or something like that. This would be a quadratic function. And if it said x squared minus 3x plus 4 equals 0, this would be called a quadratic equation. This is a function. This is an equation. I mean, technically, this is some kind of an equation because there's an equal sign in it, but this is not something you could solve. You couldn't get a number for x here, but here you could. And just to remind you again how we solve these, we get one side equal to 0. That's important. One side should be equal to 0. And then we factor, let's see, plus 1 minus 4. And then we set each one of these terms equal to 0. This is called the zero product rule. It says that if you have two things or three things or four things multiplied, and the answer you get when you multiply them is 0, one of those things must be equal to 0. So we check either this is equal to 0 or this is equal to 0. We solve this little mini equation, we get x equals -1. We solve this little guy, we get x equals 4. And these are the two x's that make this equation true. And you can always check. You know, plug a -1 in here, you get 1. That didn't work, did it? It should be -4. I wrote that wrong. It does work. LOL. -4. So if you plug a -1 in here, you get 1 plus 3 minus 4, it's 0. If you plug a 4 in here, you get 16 minus 12 minus 4, which is also 0. So that was just a very brief reminder of how these things work. So just as a secondary reminder, we're going to solve this equation the very same way. But this first thing is, it says equations reducible to quadratic, which is a fancy way of saying we're going to take equations that don't look like they're quadratic, and we're going to make them look that way, and then we're going to solve them that way. So basically, we're going to take things that look difficult, and we're going to make them into things that look easy. So like we just did, I'll do it again, just as a secondary reminder. We already know how to solve an equation that looks like this. This is a quadratic equation. You can tell because the largest power of x is 2. And so we solve this, we're like, well, can I factor this? Yes, x minus 1 times x minus 8 equals 0. -9 plus 8, that works. So I get x equals 1 and x equals 8 for these two problems. You can check and see if those work, and I promise that they will. So we already know how to solve this one. This one looks a little different. And this is when we come to the idea of reducing something to a quadratic equation. If you look, this one here looks a lot like this one here. This is x squared minus 9x plus 8. This is x to the 4th minus 9x squared plus 8. And so what we're going to do is we're going to use something that I usually call U substitution, like the letter U, not like I'm substituting U personally. And I look and I see that this thing here multiplied by the number, the secondary thing, is x squared. And if I square x squared, I get x to the 4th. So basically, the way to recognize this as a problem where you should use the U substitution method is to see, is the thing in the middle here, if I square it, do I get this thing in front? And the answer is yes, you do. If you square x squared, you get x to the 4th. And so here's a way to rewrite this. You don't always have to do it this way, but this is a good way to get started. So I take this thing here, the thing before I squared it, not x to the 4th, but the thing inside here, the thing right here. I'm going to call that u. We almost always use the letter u for this. I don't know why, but we do. So u equals x squared. Then I write down what u squared is equal to. Well, if I square both sides of this equation, I get u squared on the left, and I get x squared on the right, which is x to the 4th. And now I'm going to do the substitution part. Substitution. So instead of x to the fourth here, I can write u squared now. I'm going to circle them both in green so you can see what I'm doing. U squared equals x to the fourth. And there's an x to the fourth right here. So instead of x to the fourth here, I can write u squared. And then plus, oh, it's a minus, not a plus. Minus 9. And then I'll do it in red again. Instead of x squared here, see this is x squared and this is x squared, I can replace this x squared with u. And then I leave the plus 8 alone because there's no u's in it. That equals 0. So all I've done is like rewrite this thing with a u instead of an x squared and a u squared instead of an x to the fourth. And now if you compare this equation, u squared minus 9 plus u squared minus 9u plus 8 equals 0, it looks exactly like this equation, except there's u's instead of x's, but the letter doesn't matter. So now I can go ahead and solve this thing the way I did before. U minus 1 times u minus 8 equals 0, which means u is 1 or u is 8, which again, same answer I got up here. That's not surprising. And so we've like kind of solved this, but we haven't quite finished yet. My last step in these problems is almost never solving for u. This is what I did here. I have two values for u, but the question was about what is x equal to make this thing true. And so now I like resubstitute or back substitute. Because remember, u was equal to x squared, which means if u equals 1, then x squared equals 1. And if u equals 8, then x squared equals 8. If I solve this thing for x, I get x equals 1 and x equals negative 1. If I solve this for x, I get x equals 2 root 2 and x equals negative 2 root 2. So I've now solved this thing for x, which is what I was trying to do in the first place. So maybe you can see what I mean now when I say the last step is never solving for u. Because the equation, the original equation was in terms of x, which means my answers should be in terms of x. So this is u substitution, also known as reducing quadratic equations to quadratic. That's what this little title means, equations reducible to quadratic. In the sense that this was not technically quadratic because it was x to the fourth and x squared, and quadratic, it means just a squared term, but I reduced it to a quadratic equation and then I solved that one. So we'll do a few more examples here. What we can do here is like look and say, what would I choose for you in these? What would be some things you might choose? Well, remember, we looked here and we were like, what is in the middle that's squared in the front? And here in the middle, I have 3 times this thing squared plus 5 times blah, blah, blah. So I look and I'm like, well, if I see right here, I have 3x plus 2. Here I have 3x plus 2 squared. A good choice for you here would probably be 3x plus 2 because it's to the first power in this term and to the second power in that term. This a plus b squared minus a plus b. This, I think I would choose u equals a plus b for this one. Because this would be like u to the first, and this would be like u squared. This one's a little trickier. The e might throw you off a little bit, but if you're not sure, you might be like, well, I'm just going to pick the thing in the middle. Maybe I'll say u is e to the x. That means that u squared is e to the x squared. And as I'm sure you all remember your rules of exponents very closely, the rule when I have a power raised to a power, as I do here, means you multiply the two powers together. So this is going to be e to the 2x. 2 times x is 2x. And this seems to work because there's my e to the 2x. This would be u squared. And there's my 6 minus 6u plus 2. For this one, again, maybe you're not sure at first, but you're like, well, let me just pick the thing in the middle and see if it works. Like if you pick the thing in the middle and it didn't work, then you pick something else. It's not the end of the world. You can pick the wrong thing first and just check and make sure it works. U is a to the fourth. That means u squared is a to the fourth squared. And again, when I raise a power to a power, I multiply those powers. I get a to the eighth, which is indeed the thing right here. So this would be like u squared minus 6u plus 9. 9, not 4. Last couple. Let's see. This one doesn't look like anything yet because there's like not just one term in the middle. So this one has a little trick in it. You see that this term, that both of these terms have a -8 in them. So I can factor that out. When I do, -8x divided by -8 is x. -8y divided by -8 is y, a positive y. And now this looks a little better. Now I'm going to be like, all right, I'm going to choose x plus y for u. Because it's to the first power here, and then when I square it, I get x plus y squared. And then this is what I would do. So this would be like u squared minus 8u plus 7. Now last one, this one looks a little different because there's nothing squared or even raised to anything besides the first power. So you're like, well, how the heck am I going to do this one? Well, let's just go with our kind of general rule, which says choose the thing in the middle. All right, so u is a square root of x. Then u squared, if I square the square root, I just get x. Oh, that's what's right there. So this one would end up being 4u minus 6, sorry, 4u squared minus 6u minus 18. So these don't always look exactly the same. When there's a fourth power and a second power, and like an eighth power and a fourth power, like when this second power is just twice as big as the first one, maybe that's a little easier. Sometimes they look like this, where the one's like, this is like to the first, that's a little confusing. And sometimes it's like an expression in parentheses, not just x or y or du or whatever. So there are some variations, but they're all basically the same. So here we have just some kind of generic problems I was going to do. Find the x-intercepts is the same question as set it equal to 0. This means set equal to 0. So I say x squared minus 1 squared minus x squared minus 1 minus 2 equals 0. And there's actually more than one way to do this, but the easiest way is to do u substitution. And you can maybe notice that here is x squared minus 1 to the first power, and here is x squared minus 1 to the second power. So let's say u is x squared minus 1. Then u squared is equal to x squared minus 1 squared. So now this first term, x squared minus 1 squared, is equal to u squared. This second term is equal to u minus 2 equals 0. We do a little quick factoring. And we get this, so u is 2 and -1. And again, I'm not done yet because they wanted me to tell them what x's make this equation true, and my answer is in u's. So I said each one of these things equal to x squared minus 1 and solve that for x. So I get two possibilities. Either x squared minus 1 is 2, or x squared minus 1 is -1. This gives me x squared equals 3, which means x is positive and or negative √3. This one gives me, if I add both sides, I get x squared is 0, which means x is 0. So these are my my three answers to the question, what are the y-intercepts of that? Or sorry, what are the x-intercepts of that graph? Okay. Some things to keep in mind: find out what u and u squared are first. Figure out what you're going to choose for that first. And as I've indicated before, solving for u is not your last step. So this looks a bit like one of the ones we did up here, like this one where we had a root x in the middle and a x to the first at the beginning. So I'm going to do a similar kind of substitution like I did there. I'm going to choose root x for my u, which means u squared is equal to x. And that is going to give me a pretty straightforward substitution here. U squared minus 3 u minus 4 equals 0. Oh, this one has a little trick at the end, if I recall. So I get u minus 4 times u plus 1 equals 0, which means u is either 4 or negative 1. And again, my secondary hint was don't stop once you solve for u. Got to solve for x. My u's and my 4's look very similar. U. So if root x is 4, then that means x has to be 16. I mean, you could think about it like squaring both sides if you want to. I just think of it that I know the square root of 16 is 4. And now I get root x equals negative 1. Well, that doesn't work now, does it? There's no number whose square root is negative 1. You might be like, what about I? And the answer is not quite. The square root of negative 1 is equal to I. It's not that the square root of I is equal to negative 1. So like if you squared both sides, you get x equals 1. And you'd be like, all right, well, maybe that works. But then if you try that up here, x equals 1, you get 1 minus 3 times the square root of 1 minus 4 equals 0. That's 1 minus 3 minus 4, which is negative 6. That doesn't work. So which means that this answer is bogus. It's the word in math is extraneous. Like it doesn't work. This gives you like a false solution. And your biggest hint that there's an extraneous solution is this line right here. This is telling you, nope, this is no good. The square root of a number should never be equal to a negative number. If that happens, you've done something wrong. And it turns out, for this one, the only answer that works is x equals 16. So be careful about this. This pretty much only ever happens when you set up your u like this. If u is a square root of x, because this indicates that u has to be positive, or that this u has to be positive, and so this negative u we got here doesn't work. So keep that in mind when you're doing these. All right, we'll do one more. I'll break this video. So negative exponents, quick reminder, x to the negative 1, that means that's equal to 1 over x. And x to the negative 5 is equal to 1 over x to the 5th. That's how negative exponents work. It means you like do 1 over the reciprocal of the thing, and then you make the power positive. X to the negative k is 1 over x to the positive k. It doesn't matter what this number is, any numbers like that. So that's just so we remember what's happening here. We can kind of do the same trick here with the substitution. Maybe I'm not sure at first what to use, so I'm just going to pick the thing in the middle as my u. Then if I square that, I do like this thing squared. And multiply the exponents. Negative 1 times 2 is negative 2, so I get m to the negative 2, which works out well for me because that's the first thing here, 2 m to the negative 2 plus 2. Now I can substitute. Instead of m to the negative 2 in my original equation, I know I can write u squared. Instead of m to the negative 1 in my original equation, I know I can write u. Oh, it's 2u squared. Well, that's a factor, but this one will. So now I do some factoring. Y'all might do this a little differently than me. Y'all might like do the thing where you multiply these and then do the factoring by grouping. I'm just going to skip that because you can do it a little quicker if you do it this way. We need a plus 1 in the middle, so I'll do plus 3 and minus 5. That should work. Minus 5. Yep, that works. Which means u equals. Oh, I'll write this step out. We're almost done with this video. So 2u minus 5 equals 0, and u plus 3 equals 0. This gives me u as negative 3. This gives me u as 5 over 2. But remember, I can't stop here because I got to solve for m. Well, u is m to the negative 1. So instead of u equals 5 over 2, I can say m to the negative 1 equals 5 over 2, which implies that 1 over m equals 5 over 2. Remember, m to the negative 1 is the same as 1 over m, which means m is 2/5. There's probably a number of ways you could get from this step to this step. I'll let you do it your own way. I just flip them both upside down. That works pretty well. I can do it for the -3 as well. M of -1 is -3, which means 1 over m is -3, which means m is -1/3. This is one where you might want to try this m up there and make sure it actually works. I'm not convinced that I don't think that you'll have a problem with it, but you might want to give it a run, see if it works or not. So I'll make sure to ask you guys in class whether or not that answer actually worked. So keep an eye out. Next thing is completing the square. Bye.